The way in which this is slotting in with the agenda today, we're just following the two other breakout sessions, which have been Excited to Fly and the end-to-end sustainability sessions. I was dotting between the two of them just a moment ago, and it seems that there's some really good engagement in there, which is promising for this session as well. We're also in parallel to the BioSafe workshop session that's also running in concurrence with us at the moment. There's a note of the panelists there, which we'll get into some detailed introductions from each of them in just a moment. Firstly, I wanted to just set the scene for a very top level view of the four challenge statements that we have as part of this session. On the right hand side, you can see the industrial inputs have been narrowed down to four main challenge statements that we'll be going through in much more detail as we move through the session today. We'll go through each of them in turn. The first, reduce manufacturing cost by greater than 20% through automation, agile and digital technologies. Secondly, reducing cost and time of new product introduction NPI by 50%. The third, to realise virtual testing as a common means of compliance across cabin systems. And fourthly, to reduce weight by greater than 25% without compromising on aspects such as cost or performance. Also, if I can add, please, if you're not a panelist in this session, to turn off your camera and also to put yourself on mute, just to not interrupt the flow of the session. I think there was a couple of interruptions in the prior panel, so if you can just reduce yourself to no camera and mute yourself unless you're contributing to the panel, please, that would be excellent. Thank you. So there's a couple of things for you all to do if you can. There is operational in the background to this session a Mural Whiteboard, which can be accessed via the link shown in the top corner of the slide, but also there's a link in the chat feed for you to click on, and it should open a new tab in your browser, and you can bring up this cost, weight, performance, collaboration Mural module. Within this, if you can, what we're looking for you to do, and everyone if you can throughout the session, is to access this to add post-it notes by double clicking in each of the boxes under each of the four challenge statements, and within that put your company name, your name and your position within the company, and also a brief description of some capabilities or technologies that you have right now existing that may offer a response or an improvement to the challenge statement, particularly that you're putting it underneath. But also on the right hand side of the Mural board, please to also add in any future technology opportunities or any roadmaps or technologies that you currently feel you wish to be developing in the near future that may be supported by the bringing together of, say, a consortia or by the use of something like ATI funding to deliver. These Mural whiteboards will be collected by the ATI after the event closes, and then will be used to recontact individuals and organizations where we can identify things like common themes of interest against specific technologies and challenges. The aim of that is to help drive for some greater building of some consortia in the future. Also, please, if you another link for you to use, which brings up yet another window, which is the Slido questions and answers interface. The link is shown on the right hand side, but also in the chat feed of this Teams. Here, I'll be collecting questions within the cost, weight, performance tab, and I'll be using those questions to then relay to our panelists to get through the discussion over the next hour. We'll be running this session until approximately 2:10. So if you can start populating that now with your questions, and when we finished our speaker introductions, we should be able to go straight into the panelist discussion. So if the panelists on the chat today can have their cameras and microphones ready, what I'll do is I'll work through you all from left to right here, and if you can provide your introductions and the relevance of your interaction into this forum from your company's perspective would be excellent. So I'll start firstly with Mike Orange, Director at Csense.
Hi there, I'm Mike Orange, co-founder of Csense, Head of Business Development and Head of Engineering. Csense are specialists for lightweighting, for fast processing of composite parts, FST compliant materials and sustainability through reduction of fuel burn and the use of sustainable materials. Csense are composite manufacturers and engineers, and we offer end-to-end supply for composite components from concept work, engineering, prototyping through to product development and serial production. Csense was founded in 2014. We're located on the Hampshire-Wiltshire border. The founders of Csense had a background in Formula One, motor racing, and also Grand Prix yachting, like the America's Cup. Both those sectors pushing, weight saving and performance. And we've taken this knowledge of groundbreaking lightweight engineering, brought it into the mass transportation industry by becoming experts in fire safety of materials. And our main drive is to really reduce the reduction of the component weight and increase the sustainability of those parts towards the target of air travel reaching carbon net neutral by 2050. And our innovation really centered on composite engineering and the understanding of the characteristics of the materials, new materials that we generate, and also more efficient processing. And we've got quite a lot of parts in aircraft in flight at the moment for seats and leg rests for premium economy and economy seats. And we're working on several R&D projects at the moment, one of which was mentioned earlier with Tangerine for a comfort system. We're also working on components with sustainable materials and a sustainable seat back as well. And also we did some NATEC projects last year for lightweight, low-cost parts for aircraft seating. I think that's an intro from me then, Sean.
Thanks, Mike. Brilliant. Thanks. Great to have you on the panel as well. Thanks. Moving over to Martin, please, at Pliable.
Thank you, Sean. My name is Martin Norton. I'm the co-founder and CEO at Pliable. Prior to starting Pliable, I had a design and engineering consultancy business, and my whole career has really been in composites engineering, so very well versed on the trade-offs in cost and weight and performance that hopefully we'll be getting into today. In terms of aircraft interiors, I was part of the team that developed the first fully composite economy seat, passed 16G crash test, and weighed less than 4 kilos per passenger. So that was very much on the performance end of the spectrum. Now with Pliable, Pliable is a startup. We're part of the first cohort for the ATI Boeing accelerator. And we, in my previous career, we noted that tooling was a big barrier to products seeing the light of day. You know, it accounts for almost 50% of the cost of bringing a product to market, and we wanted to use the advances in digital technologies to lower those barriers. So we've created a frictionless B2B e-commerce platform that's free to use, and we're able to automate a lot of previously human-centric processes to deliver efficiencies to our customers. We recently worked with GK and Aerospace, and we're shown to be 44% faster and 20% cheaper than incumbent suppliers. So a lot of potential for savings in both time and cost there.
Excellent, Martin. Thanks, and great to have you on board. Next, I'll move over to Stephen at Williams Advanced Engineering.
Thanks, Sean. Thanks for the opportunity to join the panel. So I'm basically an innovation lead at Williams Advanced Engineering. I've been working with Williams for about 6 years. I'm also chair of the AirTech project, which was presented earlier. This lightweight business class aircraft seat structure. I've got a background of about 25 years working in a range of advanced engineering programs in the aerospace, automotive and space sectors. I'm also a director of a electroforming spin-out from University of London, and I also do some teaching and mentoring of innovation at University of Oxford and at the Royal Academy of Engineering. That's me.
Thanks, Steve. Excellent. Next, moving over to the next Stephen from Q5D.
Yeah, thanks, Sean. Yeah, I'm a founder and a CEO of Q5D Technology, which is a spin-out of 2 UK technology companies with a strong background in additive manufacturing, printed electronics. When we were looking, thinking about this project a little while ago, we were looking as to where additive manufacturing could actually move from where it is now, which is largely in prototyping, into mass manufacture. And we realized that one of the areas in mass manufacture that is still largely done by hand is the wiring. And it is an area that is crying out for robotics, because there is a strong push for increased functionality, increased wiring, but also a strong push to reduce weight across all sectors. And this is a technology that really does require automation, and there's a lot of different technologies out there that are trying to solve that problem. The approach that we've chosen is to create a large additive manufacturing machine with 5 axes, so it's a bit like a CNC machine, that can switch heads. And it can switch in an additive manufacturing head, or it can switch in a head that can do printed electronics, or you can use heads that can embed wiring into your component. So the idea is not to compete directly head-on with existing manufacturing techniques, to take a part that has been injection molded, or it's a sheet metal part, or in the aerospace sector, largely a composite panel, and then add dielectrics, add structural elements with the polymer, then add your printed electronics and your wiring to that component directly, to replace all the sort of hand layup that's done in wiring at the moment. And the idea is to make the whole process digital. So you're going from a CAD file, then computer-aided engineering, the finite element analysis, through your tool path and your CAM, through to sending it off to our machine where the manufacture will be automated. And the idea is to improve quality, to take out a lot of weight wherever possible, and of course, because you're replacing often labor, sometimes out in the Far East, to reduce your supply chains and reduce your cost. Thank you.
Stephen, thank you very much. And it's a pleasure to introduce our final panelist, Elizabeth from AVIC Cabin Systems.
Hello, everyone. Thank you for allowing me to be here. I'm Elizabeth Payne. I've got 3 decades plus in the aerospace industry. I started off on the shop floor and then went into the stress department, the design department, and now I'm CTO of ACS. So as you heard earlier on, ACS was established in 2018. So my job really is to bring the 5 companies together from an engineering and innovation point of view. So I've got a long journey integrating 5 companies, looking at the synergies that these products bring together and how we can improve on our current offerings and our new innovation collaborations as well. So we've started on our journey in the 8 weeks that I've been there. Very excited about the whole prospect of the future of having a new company with 5 established companies coming together with a very, very broad offering in a cabin area. So that's me.
Thanks, Elizabeth. Thank you very much. So I think without further ado, we'll get stuck into the discussion part of the session. I'm just going to move over to a focus now on the first of the challenge statements that I identified at the beginning. I'll just briefly walk through the origins of the challenge statement, and then what I'll do is I'll stop sharing the screen and reduce down to the Slido questions, and I'll be picking out of the Slido questions to the panel those that are relative to this particular challenge. So, to reduce manufacturing cost by over 20% through automation, agile, and digital. So some industry inputs and comments have fed into this really on the left-hand side. Topics and aspects such as flexible manufacturing, integrated systems, processes with fast ramp rates, the rollout of standard design or equivalent principles within cabin classes, all of them. The elimination of scrap and rework in the manufacturing supply chain to drive down costs. That's across economy, business, and first class. Increasing the level of automation in manufacture for interior cabins generally, galleys and seating, such as things like automated potting or robot bonded assembly, welding processes, essentially those things to reduce the need for intensive labor, working towards lowering costs and speeding up cycles. And also reduction of raw material costs, especially those that are currently quite expensive, like PEI or polycarbonate thermoplastics, for example, and generally to produce materials in a cheaper way that then can be cascaded into the per part costs of the supplied components. So if I just now stop sharing my screen, and I'm just moving over to now accessing the cost weight performance Slido. So there's a couple of questions I can pick up on in here, and the first one is going to be directed towards Stephen at Williams. From the AirTech presentation given earlier in the keynotes, it was mentioned about short fiber thermoplastics. I think this is sort of alluding to our thermoplastic materials challenge statement here, and also the rapid cycle processing. Within that, it still posed a continued challenge for the AirTech project. How is that the case? And then after that, I'll open it to the panel for any discussions about what might be able to be done to overcome that. So Stephen, if you can bring that one up.
Yeah, sure. Okay, well, our kind of understanding at the moment for short fiber thermoplastics is that to be able to meet the regulatory requirements of EASA, because we would be looking to use these materials as structural load-bearing materials. There's certain manufacturing variability that you can that results when you're molding with short fiber thermoplastics. So there's certainly discussions to be had around the regulators, with the regulators around this. And we don't want to have to over-engineer significantly, because that just adds weight. So we want to be able to, with a manufacturing partner, achieve good consolidation of the material and reliability of the structural performance, not just when the product comes off the the production line, but also in service as well. We don't want to have to over-engineer just because, well, we need to think about how these products are incorporated in the cabin to ensure they're protected from impacts and damage from just general wear and tear. The purpose of AirTech, we're designing a lightweight seat structure, and we don't want to choose a material and manufacturing process that it may just be innovative and novel and may have faster cycle times if we're going to have to push the weight up significantly to meet the regulatory requirements. So it's something that it's one of the kind of work streams that we've got in the AirTech project at the moment that we're kind of dealing with.
Thanks, Steve. Anyone else on the panel like to pick up a response on the challenges faced for short fiber thermoplastics processing for cabin systems? Mike?
Yeah, thanks. I mean, the short fiber processing or short fiber materials, offer a lot of advantages, because you can actually, the engineering is a lot easier to do on them if you can have a homogeneous material that actually can replicate a sort of a quasi-isotropic material. Some of the technical challenges of fiber orientation are actually doing ply books, which is a very specialist job for engineers, and there aren't enough competent engineers around. Means this starts to get opened up to more common practices of having a universal material, but then it has its own challenges. With my experience of short fiber materials is they're very hard to do on thin ply parts. You really need a decent thickness of these components to guarantee a decent load path transfer. And if you're using too heavy a fiber, then you need to have a very thick part. If you're having a thinner part, you need to use a much lighter K or filament count into your part to enable you've actually got a decent load transfer through these. So yeah, very interesting part. You can into your parts already, and you can actually create a lot more efficient structure rather than having sort of notch concentrations where you might drill through a fiber product. But generally they do have a lower property than an aligned fiber part, but it does open up a lot more opportunities for the mass engineering world to use a short fiber product. So they're very interesting and very important if we can learn more about their characteristics and rely on them.
Yeah. And I just to add to that, Mike, that's thanks for the feedback. Hybrid structures as well. We can look at incorporating tailored sort of potentially metallic interface points as well within that can be included within a short fiber thermoplastic part to just to optimize load transfer.
Yeah, and if the resin system is common, you can put some fiber path alignment over the top of a short fiber molding, so it's quite a nice way of doing it. It's certainly more efficient than just making a quasi-isotropic sheet and using that for everything.
Yeah.
Thanks to you both. I'd also like to focus on the automation aspect of this challenge statement. There's a couple of questions here. I think this one will probably be best picked up by, again, Mike and maybe Elizabeth as well. So I'll start with Mike. On automation, are Csense developing any approaches to automated manufacture? And if so, is there any technology gap or any problems that are foreseen in the future for supply chain companies being able to deliver that?
Yeah, I mean, certainly, to reduce those costs by that much, the materials are fairly expensive. So the automation and the efficiency of the process is the obvious concentration point. We may get new materials we don't know about that are much cheaper, but really the automation is the point of efficiency. So most of that is unlocked by scale. So if you've got enough components, you can then got enough investment, you can amortize your tooling across those. So we've certainly been looking at the fast processing of materials and press molding. We're looking at the automation of the parts. So those parts are fairly well covered. I think the areas we haven't really got into at the moment is, the bonding together of the seat backs or composite components for interiors, to actually put the glue paths down and to have the assembly as automation, and probably the ply cutting as well. So we've gone into the main parts of the pressing and the trimming that's automated, but actually the stacking up of the plies and the material of the plies into the molds, and the assembly of that is probably the areas where we see our next level of automation that we would go for after the trimming and the pressing molding.
Thanks, Mike. And Elizabeth, across ACS, you've got a number of companies and a number of manufacturing and assembly lines. Is automation a challenge for you across the lines? And is there anything AVIC are currently doing to develop automation processes for assembly in interiors?
So what we've got a basic challenge of understanding what our foundation is and bringing that together as a standard at ACS. So what we're doing, first of all, is we're looking at automating the value. So we want to drive out the waste, first and foremost, of everything that we're doing. We've also got the challenges of bringing in new innovation that is fully developed, so that when it goes from the TRL, MRL life cycle straight into the MPI life cycle, that it is already proven. And this is where the automation aspect of it is all about the value stream and not so much the product itself at this moment in time. So we need to look at how we can flip that around.
Thank you. There's also a specific question I'm seeing through the Slido here. This one's going to go to Stephen Williams again. How have allowances been made for the seat mechanism in the kinematic path on the AirTech project?
The seat mechanism design is not part of the AirTech project, but what we've done is taken a standard, it's termed a Pancake kinematic, and it's been package protected within the design. So from that perspective, yeah, it's been included, and we've made some reasonable assumptions around the structural kind of stiffness and strength and performance of that kinematic for the CAE work.
Thanks, Steve. Just driving back to the automation questions, we had a response from Mike and Elizabeth as well. Martin, from Pliable's perspective, you operate a lot in digital, and there's a lot of things in your sort of portfolio that are in this sort of area. Is there a comment from your perspective on automation of composites manufacture?
Yeah, so one of the reasons we started Pliable was because I've been a composite engineer since 2007, and there has, progress in manufacturing is slow, but if you look back, there has been huge strides in automation, increased automation in composites manufacturing, and this has been driven by aerospace, but also the automotive sector and their drive for reducing weight to increase efficiency. But there's still a long way to go. Our focus is on the areas right at the beginning of a product life, and every single composite component requires a mold. And what we realized was that a mold tool is a mathematical function of the geometry you're trying to produce. So we now use computer vision and AI to automate the process of designing a mold tool, something that was previously entirely human driven, and this does lend itself to reducing cost and reducing lead time. If anyone saw the presentation earlier, we did a study with GKN and showed that we were 20% cheaper on tooling costs. That goes a long way. Usually it's tooling accounts for over 30%, around 50% of cost of bringing a new product to market. And as Mike Orange says, depending on the numbers you need to produce, you can amortize that. But it's still a significant barrier and something we're trying to reduce. But new technologies, new materials, new processes like short fiber, like thermoplastic, are going to still require more tools, but reduce the part price.
Thanks, Martin. And Stephen Bennington over at Q5D. I mean, the printing technologies for manufacturing of components, I mean, inherently that's an automated process, is it not? And does that bring great things for interiors in the future?
Yes, I mean, obviously we're not looking at automating the manufacture of the composites itself, but all the electrical systems that you add to those composites. So, for example, a big project we're doing with Saffron Seats is taking the composite panels that are in the first and business class seating, and then looking at ways of automating the addition of the wiring on those panels. So at the moment, if you look at them, they have these embedded mounts, and they have standoffs and then wraps. They're quite heavy structures, actually, and you can take out a lot of weight. I mean, there is a lot of regulatory hurdles to overcome there, but if you can lay down that wiring directly onto the composite panel, either in printed electronics or through the cabling itself, and just embed the cabling itself into polymers onto that structure, then you can take out a lot of weight. But also, each one of these components are of course handmade. The layup of them is all done by hand, and replacing that labor cost with amortized cost of capital can save you a lot of time and money. And like I said, the whole point of it really is, and the bit that really gets me excited, is that you're taking out quite a lot of the design. So normally on these things, when you're designing a new component, you would design the structure and you would stress that structure in finite element analysis, and then leave holes in it for which then you would add the wiring. But the way that we're working with Siemens NX is to combine all of the wiring and the design of the wiring into the structural component. And that means your finite element analysis is now testing the entire component at the same time. So it's a different way of looking at the design process. And of course, once you've done that, and then you do the toolpath calculations and send it off to the machine the next day. So that life cycle of design doesn't mean you have to send everything out to distant manufacturers who are doing your wiring and your terminations and your structure. Everything's done by you in-house and done very, very quickly. So the design time can be very quick, and you can save a lot of cost. One last little thing I might want to say is that not only are you taking out all the standoffs and sheathing and all the other ties and other stuff that you have in this structure, which can be quite significant weight. Most wiring is chosen based on its structural strength, not the electrical carrying capacity. Usually you can get away with a gauge of wiring which is tiny compared to the gauge that you're actually using, because somebody's going to manipulate that, they've got to manufacture it, and then the people who are installing it have got to manhandle it, and so the wiring is usually over specified in terms of its electrical capability. If you can use printed electronics, or you can use very fine gauge wire, you can also take out weight and cost in the materials.
Thanks, Stephen. I think with the moving on of time, unless there's anything else for the panel to add, I'm going to move on to screen sharing the next of the two challenge statements. So just bear with me while I bring up the slide pack. Apologies to skip through these again. But if I just now quickly introduce numbers 2 and 3, so these kind of quite inherently link to each other, the 2 points. The industry comments and inputs that have fed into these two challenge statements on the left-hand side. The two challenge statements themselves, we've got reduced cost and time of new product introduction, so NPI, so the development cycle of introducing new parts, by 50%. And then also realizing virtual testing as a common means of compliance across the cabin system. So feeding these have been comments such as getting the product in front of customers, factors that drive airlines' choice. Interior crash testing is oriented to metallics inherently. Long lead time for composite tooling. Automation and scale these directly to NPI. Customizability at low cost is a requirement or a need. There's a need to reduce the cost and lead time for FST testing, and also for 9G and 16G mechanical tests for qualification of new products. And this would all be very well supported by the development of virtual and mechanical or fire performance modeling for cabin structures to eliminate the need for physical FST or mechanical testing. So I'm going to move the panel over towards maybe responding on some of the points that we have in here. I think I'm going to focus on the tooling aspect, and Martin, I'll come to you on this one. So this is in the cost corner of the triangle that we have between cost, weight and performance, really, and also on the time aspect of this NPI delivery. You know, tooling can account for up to a third of the non-recurring costs in some cases of a manufactured part. And as we move towards, you know, even more complicated interior structures, we've already talked about thermoplastics and potentially then tooling that require things like very high temperature processing or very quick cycle of temperature up to hot and to cold. Requirements for low thermal expansion coefficient when you're processing at high temperatures. What further technology development is needed to get composite tooling cheaper and to help with this the two challenge statements I brought up?
Thank you, Sean. I'd say that's an excellent question and one that we are very passionate about solving. In terms of cost and lead time, to a certain degree, those two statements go hand in hand. You know, if you just ignore the equation that you can often pay more and get something faster, but if you just think about the processing time, the longer these are, the more you're going to pay because there's more hours involved. And so automation is going to play a part in reducing costs. I think there's further work outside of, you know, these four walls in terms of the materials and processes that can be developed. And really, we see the future for tools being, you know, currently a mold tool is actually quite a passive bystander in the manufacturing process. And as Stephen was talking about, Stephen from Q5D was talking about their technology becoming part of another structure. And we see tooling really becoming a critical part of the whole manufacturing process. So active tools, smart tools that are able to control their heat up and cool down rates, directly responding to the part that's within it. I think we've talked about thermoplastics, and there's a lot of benefits in thermoplastics in terms of cycle times, but if you look at also thermosets, whatever we can do to remove the autoclave from the equation is going to help with reducing component cost. And I think that increasing the scope of what a mold tool does is going to play a part in both the thermoset and thermoplastic equation, and asking more of it. And that's something that we're doing. So if you look far in, well, hopefully not too far into the future, about the types of process choices that we have as mold manufacturers, there's been a lot of talk about how we can use additive manufacturing and use that as a use tooling manufacture. Where I see it as being really interesting is on the larger end of the scale, so large scale additive manufactured tools where you can, through the process, integrate sensors and heating channels much more efficiently than you can with, say, subtractive processes. There's still a long way to go on that in terms of understanding the CTE requirements, but some of the tools that we are actively working on developing into our online platform are CTE calculations, flow calculations, so that all of this engineering work can be automated and done in the cloud in parallel, and ultimately deliver those right first time tools to the customer so that they can be producing better parts more efficiently.
Thanks, Martin. You mentioned printed tooling being potentially used as I suppose, a means of reducing that NPI, maybe bringing the lead time for tooling down significantly compared to what it's like at the moment. Stephen, you have anything from Q5D side to add to Martin's comments there?
Yes, I mean, obviously we have looked at the idea of printing molds as well, but I think there's another way you can look at this, is that often there are components or parts of the of your piece that are difficult to do in an autoclave or with a composite. And obviously, we quite like the thermoplastic short fiber composites because you can print those. So you can add more complex components. You can keep the molding relatively simple and just customize a component quite easily, with additive tools. I think you'd never ever really want to use an additive manufacturing method to make the whole piece. I mean, that's just really the wrong way to go. But if it is a customization, or it's a small part which is difficult to do in any other way, then additive is absolutely perfect for that. And that's the route where it should go into proper manufacturing. Apart from, of course, all the usual places where it's used in the prototyping.
Thanks, Stephen. I've got I have two more questions, I think, on these two challenge statements, and I'm going to open them out to everyone on the panel. I've got one from Anonymous on the Slido. It's about certification, and I think it's going to be inherently related to NPI through the certification of new product or new designs. How can we accelerate the certification process to get new technology and new product into service quicker? Does anyone wish to pick that one up?
I'll have a go. I mean, certainly there is, it's Jaffa here from Csense. There is a huge barrier to certification. It could take 12 months to certify parts at the moment. There's a big resistance to sort of digital, artificial intelligence mapping of actual to certification. It seems to be done a very manual process, and I hate to say it, but even in the rail industry, if you can prove that the real life mirrors what you're predicting, you're allowed to then go and start using some of the simulation to prove some of the results. Whereas the aircraft industry really does rely on manual physical testing. So there's not much digitization, not much simulation that's allowed to come into the process. And also there's a bit of a traffic jam in all the testing labs. I mean, I think there are a lot of seating companies now who want to have their own test facilities so they can speed up their own process of development and certification, because at the moment we're relying on one or two labs around the world, and those seem to be fully booked up. So it's something that people are trying to address to get products to market quicker, and I can see that happening with the seating companies.
Thanks, Mike.
I'll just jump in. I think nobody wants to compromise quality. The aerospace industry has an incredible track record of quality and safety, and nobody wants to compromise that. But it is a barrier to new products being developed, just the cost and lead time. Number of empirical tests that has to be done, and I would back Mike Orange's comments that we should be doing more to onboard simulation tools as a part of certification.
Thanks. You both. Sorry, Elizabeth, go ahead.
Yeah, just a point. We've lost a bit of the old-fashioned National Advisory Committee of Aeronautics type data that we could draw from, or the Royal Aircraft Establishment data, and that laid a foundation where quite a lot of product could go into the market in a rapid way. And so if we could look at maybe improving the baseline, so the bottom of the pyramid, so that we can start to accelerate the development into the product line by having a foundation that everyone can draw from, that's possibly a way that would benefit all the OEMs and the people who are producing product.
Thanks. I think the responses have sort of led me quite well to the other question I had on this these challenge statements, which was on the virtual testing challenge statement particularly. Our statement is to realise virtual testing as a common means of compliance across cabin systems. And again, this isn't just an open question to the panel. Where are we with virtual testing, and what confidence level does anyone have in what is currently available, and where can we go to make it better? Does anyone want to pick that one up?
Yeah, there's quite a bit of work being done with some of the suppliers on automating a lot of the testing pyramid, but it's getting the final buy-in. from the regulatory bodies. So it does go back to certification bases that's quite inhibitive of this virtual simulation.
Yeah, I can probably add to that as well, that on the AirTech project's a good example that we're following the kind of the testing pyramid. So we're working with the supply chain to innovate the resins, but also we're developing from coupons up to parts, but in parallel we're also developing the full concept. So we work in a very much a parallel way. So we're trying to speed up product development by working in parallel and continually sort of just improving and refining. As you get test data back, you can quickly sort of update the models and rerun the models. But in an ideal world, you get brilliant sort of correlation with your test work. So the tests just become the sign off, and all the development work, it can all be done in CAE. But, that's easier said than done it's much easier in metallics perhaps, but when you've got much more complex composites or hybrid structures, especially in dynamic load cases, it's hard. But yeah.
Thanks, Steve. We're moving towards our sort of final 15 to 17 minutes. I'm going to bring up the final of our challenge statements, because I think there's a huge amount to talk about in here, and I think it's probably one of the more important ones in the statements that we have to go through today. Let me just share my screen. I'll bring up the summary and we can go through this one together again. So the final one, challenge statement 4, is to reduce weight by greater than 25%, but that's without compromising on cost or performance. So cost neutrality, or even lower cost than current components in cabin, or equal or better performance. The feeder comments from this on the left-hand side have been things like improved functionality without increasing cost or weight, cost, weight, performance, consider them all together as a sort of intertwined triangle. To reduce weight of all cabin furniture items by 15% minimum. 15% weight reduction is easy for structures. Non-structural weight from fabric, foams and trim, selection of technologies to lead to viable product, biomimicry approaches for high-performing components. Much more excess weight and opportunity is in the electrical and electronic subsystems of the cabin, and also to increase the use of composites, particularly in the economy cabins area, where it may not be so prevalent as the business in the first-class seating at the moment. To reduce weight, targets including aluminium fuselage brackets, overhead stowage, seat legs, rails. Lightweighting is generally needed, but we need that at neutral cost and durability. So I will move to a question which is high on the priorities that I've got in the Slido interface. Bear with me while I bring that up so I can read it out. From Thibaut, and the question reads, and this is for everyone on the panel: is it realistic to achieve significant weight savings, say 20 to 25%, at the same cost and quality? If not, can we value in the pounds per kilo saved for cabin applications? Does anyone care to provide a response on that?
Shall I have a start off on that one?
Sure.
So I think, a 20 to 25% weight saving by using composites from metallics is very realistic. I mean, if we look at an aluminium to a carbon composite, we might have a 40% weight saving just due to the density, and it's relatively easy for composites or carbon fiber to achieve an aluminium type property. Composites themselves generally are expensive materials, and metallic parts are cheaper generally as a material, so it is quite hard to do it for the same cost. But then there are a lot of aluminium parts that are machined from solid billet and not welded or not fabricated. Those aren't really techniques that are adopted in the cabin. So actually, when you find a lot of quite inefficient metallic machining, especially from large billets, it is quite realistic to get a composite part that is cost effective and is effectively a cost neutral lightweight option. Again, certainly if it's got the scale, it helps. And what's the next part of the question? What's the value in kilograms saved for cabin applications? Well, it's often quoted, and I don't know quite where the source has come from, but 1 kilo could be anything from $50,000 to $80,000 over the lifetime of a plane. If an interior has, let's say, 3 refits during its 30-year lifespan, so maybe 10 years for a life, probably $50,000 to $60,000 per kilo, maybe divide that by 3, $20,000 per kilo over the 10 or 12-year lifetime of the part. So that's my best sort of industry gathering of my experience of people telling me.
Yeah, I also think that interiors can't be looked at in isolation. It really is part of the fundamental design of the aircraft and the integration of the interior into the aircraft, because a lot of the overweight conditions are due to the stiffness of the substrate that you see. So you end up with an interior application coming in far too late in the design life cycle of the aircraft.
Thanks, Elizabeth. You set me up perfectly for the next question, which is priority 2 in the Slido list that I have, which is what's the weight and cost opportunity for making seats more multifunctional or integrating them? How far off are we from a more integrated cabin seat, for example?
So I'll just jump in here. So this was something that I mentioned in the presentation that we gave this morning, was that ATI's Fly Zero program offers an opportunity to rethink how you take all of this sacrificial mass that we're using for aircraft seat structures and actually completely rethink the cabin and use that mass to be designed as part of the overall kind of aircraft structure. And I think then we can create more efficiency. And obviously that would require a complete rethink of the cabin. But from what I understand, that's what Fly Zero is all about. It's the opportunity to, just rethink aircraft design for 2035.
Thank you. Anyone else from the panel?
I could perhaps say something, but although it's referring back probably to the previous question, is how much weight can you save just on easy wins on the wiring, on seating and other components within the aircraft, and it's difficult to know exactly, but you are talking about 1 or 2 people probably on a short haul flight kind of thing. You're talking in the tens of kilograms saving just by taking out some of the heavy standoffs and then using appropriate wiring and switching to printed electronics where possible. All of that's not difficult to do technically. I mean, it's difficult in regulatory terms, but pulling out 50 to 100 kilograms out of an aircraft cabin is really easy even on a big aircraft.
I also see, Sean, that quite a lot of the seating at the primary load path is still metallic, and actually a lot of the composite weight-saving parts are all sort of secondary comfort features or seat backs or panels, rather than the sort of lower structural members. So, and some of the testing that's carried out precludes really the use of that. So we're seeing primary airframe structures and wings going into composites, and I don't see the actual load-bearing structures of the interior sort of following that. I think there's a little bit of risk management there that we could be pushing a bit more to get some of the weight savings for that.
Thanks. So from the cost perspective, so we're looking for this lightweight saving 20 to 25%, but we don't want to increase our cost. One of the questions that's come through is why are high performance lightweight materials currently so much more expensive? Does anyone care to pick that one up?
Yep.
My experience is that they are coming down, and there's still a long way to go, but probably the best way to achieve that is by getting a global scale and generally increasing the global proliferation of composites use across all sectors, not just aerospace. In terms of glass fiber and composite production, the wind energy is doing a great job driving those numbers up. And therefore cost of those materials down. There's a long way to go yet. And there are still challenges to increasing the proliferation of composites use in interiors, FST being one, but also part price being another.
Yeah, certainly the composite materials are expensive compared to metallics kilo for kilo, but you are using less of the composites. But actually, you have to look at the through life cost saving that the composites give you, and so the actual ticket price of the unit is far outweighed by the actual long usage or the through life costing of it. Plus also composites do quite a few things that, that add added advantages. If you make a composite seat back, you can already incorporate some of the wiring, you can incorporate all the holes in the brackets. So we had an example where we did a seat back where a seat back used to be made of 40 different components in the bill of materials that the customer used to fit out and fit to their seat backs. And when we changed that to a composite part, it was a single seat part component. So the bill of materials and the tracking within the company is a lot easier because you can actually integrate a lot of the parts in it. And that's the beauty of the composites, is to do the design properly, incorporate all the features into it so that you don't have any post-processing. You've already coloured it or you've already added the finishes to it. So the initial materials can be expensive, but reduce the amount you use of them and then get the through life cost savings. And as Martin says, the more we use of them, the prices are coming down. But it's in its infancy compared to the metallic industry and how much is used around the world.
And it's also linked to the bespokeness of interiors. So the run rate, the repeat builds that happen with the interiors are a signature piece with the airlines. So they do like their bespoke angle on it. So it's finding that sweet point of, where can we catalog something and where can we put the bespoke signature look in when we're using these brand new materials and reduce the numbers, so of the parts within the product. So it's a bit of trade, and understanding that trade is where the success will come from.
I mean, just an additional point here with the AirTech project. We're also looking at the load bearing structure being composite. Yeah, for sure there could be a significant tooling investment involved compared with metallic, but if the product is used on the airline and saving fuel because of its lighter weight for a number of years, then the economics stands up. And also through design and engineering, we can enable refreshes of the kind of trim parts around a core structure. So the benefits of the investment over a longer life, as Michael said, you need to look at the whole kind of life cost is key. So I think, to be honest, the amount of money that can be saved from just taking weight out of the cabin due to fuel saving is so significant that, moving to composites from metallics is kind of a no-brainer, really.
Yeah, I mean, certainly in the calculations we've done, if you have an aircraft with a perfectly good set of aircraft seats that are generally going to last 10 or 12 years, if you replace the whole lot, if they were metallic seats with a composite seat, the seats would pay for themselves within the first year, and you'd get sort of 10 or 11 years of actual cost savings in it. So it's a huge driver for cost, is the weight saving.
And so that would mean that there would have to be a movement from cost focus to performance focus. In this.
So you've got to outweigh the through life cost against the ticket price of installing those parts. And at the moment, the pressure very much is in for a cost neutral lightweight option. And we are all striving to get there, but you have to look at the longer term saving, and that's not often appreciated by companies that do leasing and wet leasing and all the sort of short term opportunities that people see.
Yeah, just adding on to that point is one of the real benefits that or drivers to automation that we saw was when automotive picked up the requirement for using composites in their structures. And that was driven by regulatory requirements to reduce their carbon emissions. And we talked a bit about regulatory requirements or barriers to implementing composite structures in terms of having to over-engineer them, which obviously affects cost and performance and weight. But I think there could be more driven to increasing efficiency of the global airframe.
Yeah.
Thanks very much. We're into the last 5 minutes. We're going to be wrapping up at 10 past. I think I've got more than enough in the next question to tide us through to the next 5 minutes. I'm going to direct this one at Mike, because I know you're very active in this area. This is from Slido. Do you see a cost reduction possibility through the use of recycled material? You're muted, Mike, sorry.
Yes. I see a possible reduction in cost. Sorry for that. Yeah, they're very interesting recycled materials. I mean, we see a great push towards, carbon net neutral by 2050, and sustainable and recycled materials that contribute to that. Recycled materials generally probably do have a lower set of properties than virgin materials, but there are lots of parts of the aircraft that see a lower loading than actually, so for instance, we can use recycled materials into some of the business class seating or first class seating where we don't have the high density economy class and head impact crash testing. And there's a lot of parts of the aircraft seat or the interior that where we're trying to replicate aluminium properties and metallic properties, which are, matched to some of those recycled properties. So yeah, I think there's a great reduction possibility of using recycled materials to lower some of the cost. It's very exciting. We're pushing quite a lot of development projects that way.
Elizabeth, do you have anything from ACS? Are you looking at sustainable and recycled material for any of your subsidiary companies?
Yeah, we all know that we all eventually will have to sign into the ISO 14000, environmental management requirements. So, of course, it's front and center of our radar. I'm still on the journey. I've only been in my position for 8 weeks, so I'm still on the journey of reaching out and fully understanding what we are doing as a business. But yeah, for sure, it is front and center in our strategy.
And just to pick up on the recycled materials, there's a difference between being able to use a recycled material once, to use a carbon fiber and get ELG to recycle it and turn it into a felt. It's hard at the moment to create a business case to use it too many times. We're also using sugarcane byproduct as a feed-in stock into the PFA, the bioresin products we're using. So we are trying to incorporate recycled materials for all the right reasons, but it is a limit to how many times you use it, unless we start talking about thermoplastics, and maybe we're talking about recycling of thermoplastics by actually repurposing products and turn them into other moldings. So that's also another very interesting part, and I think a lot of the consumers are really bought into that. They see that as an opportunity in automotive where parts can be repurposed into it, and they expect it, I think, into aircraft. So we've got to listen to consumer pressure to say, what are we doing to use recycled materials and to use sustainable materials to satisfy the consumer's demand. They're leading the charge in automotive to actually drive the automotive industry to come up with eco sort of friendly cars, and we're not doing an awful lot in the aircraft interiors from consumer pressure on it, because it's really the tier one seating companies driving the products.
Thanks. I've got time for one more panelist to respond on recycled materials, if there's anything from your perspectives.
Yeah, so I think I look at recycled materials and sustainable materials in the same bucket. There's a lot that we can be doing to increase the sustainability of the products we make. From our side, just on tooling, there's a huge amount of waste. Can we be using getting virgin products and recycling them into tooling? Can we be using natural materials as a tooling product? And what can we, when we make a composite tool, we often use a master pattern. What can we do with that master pattern to recycle it? These are all research streams that we have ongoing at Pliable to reduce the overall impact of the composites products on the environment.
Thanks, Martin. Thank you, everybody. I think that's going to bring us to the end of the session. I've just got a 30 seconds to close us out. Firstly, I wanted to say thank you very much to all those on the panel. We've had Mike from Csense, Martin from Pliable, Stephen from Williams, the other Stephen from the Q5D, and also Elizabeth from ACS. So thank you all very much for the discussions. I think we have a 5-minute window now before we move over to the closing plenary sessions. So that's going to give you a perfect opportunity to access that mural board and put your company name, information and technology capabilities in there. So thanks again to everybody. I'm just going to close the Teams meeting. It was very nice to have the chat and to meet everyone on the panel. Thank you.
Thank you.
Right. Thanks, Sean.
Thank you.